Hi, and welcome back. Today we're going to be asking ourselves the question of what is an atom exactly? And if atoms truly are the fundamental building block of all matter, how do we know that they exist? Okay, so let's start once again with Dalton's atomic theory that he figured out around in the 1800s. And of course, Dalton came up with these postulates based on his experiments with gases. And that is that all matter is composed of these small indivisible particles called atoms. Atoms of any element are identical in properties. And we're going to find out actually a little bit later in the course that both of those aren't 100% true, but they are really, really close. Dalton also postulated that atoms of different elements are going to differ in size, mass, and other properties, and that's really what makes different elements different. And he also came up with the idea that atoms are going to combine in whole numbers to form different molecules, and that you basically, in a chemical reaction, are mixing and matching, you're rearranging, you're adding, you're subtracting different atoms to form different molecules. Okay, so this is all fine and good. It's a nice idea, but the real question might be, how do we actually know that these atoms exist? And the simplest answer is because we can actually see them. So let's have our own little thought experiment. On the left is a painting by Gustav Klimt, and he used gold leaf. They actually used the element gold to give the painting its luster and its shine. And let's say we went up to the painting and we actually removed a piece of the gold leaf. If we were somehow able to evade the police on the way out, we could take that gold leaf and we actually could begin dividing it again and again and again, just in the same way of Democritus and his thought experiment. And we could break this thing apart and keep going, making it smaller and smaller and smaller, until ultimately we got down to the nanomolecular level. So this is really quite tiny. And we would see these things, these little kind of spherical objects, and these in fact are gold atoms. Each one of these spheres that you see here is a gold atom. And this particular atom cannot be divided physically any further. We actually can divide atoms using various forms of nuclear energy. So the atomic bomb is in fact a representation of breaking apart atoms even further. But just kind of using day-to-day techniques of breaking matter apart, cutting it, peeling it, we would be unable to divide the atom any further. And in fact, we actually can manipulate matter on an atomic level. You can see here these are two different pictures. This is using scanning tunneling microscopy. So we're actually looking at individual iron atoms in this case, and they have used kind of a tip of this instrument to drag these iron atoms. In this particular case, it was the company IBM doing it, and they made a Star Trek logo as well. And so we are actually fundamentally moving matter at its smallest level around in this case. So another good question might be, how do we know that molecules exist? And the simple answer is that we can see them as well. And so once again, John Dalton posited that molecules are nothing more than combinations of atoms. And we have a variety of techniques that exist now. This right here we're looking at is atomic force microscopy, and that is that we take molecules and we lay them on a surface. In this case, it's a surface of gold. And then we take a small cantilever. In this case, it's got a nanomolecularly small tip, and we actually drag it backwards and forwards over the object. And of course, the molecule has a greater height than the surrounding surface, and so as it's being dragged, it sees the molecule, and then it drops back down, and then it comes back and it sees the molecule, and then it drops back down, and so it can kind of draw an image of the molecule. And so we can see here, these molecules, these seem to have 5 rings. This is the pentacene molecule right here. Every one of these vertices actually is a carbon atom in this particular case. Okay, so if we are convinced that, in fact, that most of matter is in fact composed of atoms, we can see them. And these atoms, as you can kind of see before, are these little spheres. The next question might be, what is the anatomy of an atom? What are they composed of? And an interesting thought experiment is that if we were to take an atom and we were to blow it up the size of North America, we would see, in fact, that almost the entirety of the atom is dead space. It's empty. And in fact, it's really just two things. We have this nucleus, which is the center of the atom, and the nucleus would be about the size of a department store in Kansas, so it's right dead set in the middle. And the rest of this is this voluminous space, and we're going to talk about what that actually is made out of. Okay, so atoms are in fact composed of three pieces, and these three pieces are subatomic particles. Subatomic meaning smaller than the atom or part of the atom. And as mentioned earlier, we have the center part, the nucleus. And the nucleus is going to be composed of two of the three subatomic particles. We have the neutron, and we have the protons. Okay? And these exist in that tightly packed center part of the atom. And then, of course, we have all of this voluminous space out here, which is composed of these whizzing, whirling, quickly moving third subatomic particle, and this right here is going to be our electron. Okay? And we're going to spend quite a bit of time discussing each of these in detail, because they each play an important role in describing the properties of each of the elements. For right now, I'm just going to focus on one of the three subatomic particles, and that is the proton. So protons are, in fact, what gives an element its identity. So that if you get helium from the sun, which the sun is mostly helium, or if you have helium in a balloon, as in the case of this crazy person who seems to be in a lawn chair or something like that, floating off into the distance, both of those cases, helium is going to have the same number of protons, because what makes an element is in fact the number of protons that it has. And in both of these cases, helium has 2 protons in its nucleus. And so this kind of goes back to one of the tenets of John Dalton's atomic theory. So John Dalton said that elements were unique in their size, in their mass, in their other properties, but really what makes an element unique is in fact how many protons it has in its nucleus. And so what makes carbon carbon and what makes this diamond a diamond is the fact that it has 6 protons at the core of every single one of its atoms. And what makes this beautiful copper kind of earring or necklace or woven object is the fact that at each one of these copper atoms you have 29 protons at its nucleus.